Hi, my name is Dave Lannom with Monro Training, and welcome to today's segment on basic electrical. Today, we're going to be talking about using schematics. So let's talk about our agenda. Let's briefly talk about why schematics. We'll talk about using the all data tools, always keeping it simple, and then we'll do a quick review. So, why are schematics so important? You have to remember that a diagnosis is not a procedure as a test, but it's actually the result of one or more tests. And just like dissecting the DTC, a strategy and understanding of the faulty circuit needs to be had. If we understand how a circuit should work, it makes quick time of testing. Why it doesn't? And quicker testing always means quicker diagnosis. And that's less downtime for the guest and better productivity in the base. Remember, we've got to keep it simple. When we look at a schematic, just like looking at a map, I mean, if I started at home and I tried to get to Miami, there's a myriad of ways to get there. But am I worried about that? No. All I'm worried about is the one path that I need to be on. Kind of like we talked about in symbols. It's back to Disney. When we can visualize what's going on in the schematic, it makes our life just so much easier. So let's see how we can take a schematic, break it down, and make it easy for us to use using the tools that we've got in all data.
So let's take a look at using the All Data program to help make our life just a little bit easier. Now remember, we can select year, make, model of the vehicle that we're working on. In this particular case, we happen to be working on a 2015 Toyota Camry. Now, we've used that vehicle before, so we could have gone back to our recent vehicles and selected it there as well. So, with that said, if I'm looking for a schematic diagram, the first thing I'm going to click on is diagrams. And there's two choices. We have either the electrical diagrams, which are the absolute original equipment, or we can use the interactive color. And I'm going to choose the interactive color because what it's going to do is it's actually going to allow me to do some tracing and make my job just a little bit easier. So let's say that in this particular case, we wanted to look at, say, the horn circuit. So we're not working on a hybrid, so it would be except a hybrid. And then at that particular point, we'd be able to pull up the schematic of exactly what it looks like. So what I did is I clicked on that picture. And now what I want to do is I just want to do a little bit of highlighting. So we'll talk a little bit more in detail about how relays work. But if I just want for the short term, I want to take a look at the power. And I'm going to start right there at the fuse. And if I highlight that, all I have to do is click on that line. And when I click on that line, what I'm actually able to do is I'm actually able to highlight particular areas that I want to look at. And I can see exactly where the power flows through that. So I can see that I've traced it all the way out and it made my life very, very simple. So now I've got an idea on exactly what I'm going to be working on. I can trace it, I can look at it, and I can bring it down to just the particular areas that I'm working on. Some of you are thinking, okay, Lannom, yeah, I know why you chose a horn circuit because that was easy. So let's go back and we're going to go to another one. We're going to take another case, only in this particular case, what I want to do is I want to go back to the vehicle and let's take a look at what a little bit more complicated diagram. And let's say at this particular point, what we want to do is we want to do powertrain management. And again, we're not working with a hybrid, so we're going to take the engine controls. Only this time, what do we have? This time, we've got 5 pages. Well, maybe it's a concern, maybe it's not, because in any case, whatever it is that I'm going to decide to work on, let's say I believe I've got a bad ignition coil, but I need to know the signals, I'm still able to go and look specifically at the ignition coils 1 through 5. And in the same way, if I highlight that component, there's everything I need for that ignition coils to work. So we can follow it all the way back up and we see that ignition coil gets fused power. And then we could follow it back into the PCM to see the ignition drivers. So regardless of how complicated the schematic might seem at first glance, remember, just like when we were looking at the highway traffic, we really weren't concerned about Highway 95 if we were traveling on Highway 75 and all the other noise that we didn't need. We can actually click right there on the hide wires and we can actually make that disappear to make it the same simple schematic, just like we had on the one that we started.
So at the end of the day, what are we looking for? We're good. Let's stay with that ignition coil thought. Let's say we had a P0301. And as always, we're going to go back to the very early modules of dissecting the DTC. And what were we looking at? We're looking at a number one cylinder misfire. And we've already tested it to see that it has no spark. So at that point, what do we need to find on the schematic? We need to find the source. We need to find the load. And we need to find the complete path for current to flow. And let's see what that looks like.
Let's start at the top. Now, what I am going to have to do is I'm going to have to zoom in a little bit to see exactly what I'm looking for. But remember the three pieces that I was looking for. I was looking for a source, and since we've already highlighted it, we can see the 15 amp ignition fuse. If we follow that path down, is what's actually powering the coil. Now, when we take a look at the other signals, we can see that there is a ground, and that ground is pretty solid right there. And then we take a look at the load. So what was the load? The load was the ignition coil. So what do I need for a complete path? I need power down to the ignition coil. And then I'm going to need to send an ignition signal. So with that being battery positive, then at that particular point, I can follow the signal back on the yellow wire, back down to the engine control module. And at that particular point, there's my complete path for current flow. So how would that coil actuate? That coil actuates using basic principles of electric magnetism, that every time that I collapse the magnetic field, I induce a voltage or a spark. So I always have battery positive power. And if I wanted to fire that spark plug, I basically apply quick ground to it. When I release the ground, the magnetic field collapsed and caused a spark. So what should I see? I should see battery positive power coming in, and I should see on the other side, I should see a signal, a ground signal flashing. So I have my source, I have which was the fuse. I have my load, which was the ignition coil. Now I have my complete path for current to flow. I should be able to see battery positive, a fluctuating ground that I can look at with my meter in a frequency mode. And at that particular point, the ignition coil should fire. And if that ignition coil didn't fire, at that particular point, I knew I could verify I had a bad ignition coil.
So let's review. Remember, no matter what, no matter how many different paths there are on my map, always follow the single path. The electricity is only going to travel on that single path to the component. Remember, use the power of all data. When you're using the power of all data at that particular point, you can highlight anything on the screen. You can identify the source, you can identify the load, and you can identify the complete path for current to flow. Now that we've got a thorough understanding of the schematic, now we're prepared to move on into meters and to begin to use our meters and the power of our meters to do good tests that lead to great diagnosis. Thank you.